In this video, we're going to talk about the inverse of trigonometric functions. We're going to go through a detailed explanation and then look at some examples. Since sine, cosine, and tangent are periodic functions, which basically just means that they repeat over a certain period, they are not one-to-one functions. We can see this by using the horizontal line test. So if I draw my horizontal line on my sine graph, you can see how 1, 2, 3, 4 points. And in order to pass the horizontal line test, remember only one point can go through that line. Again, on the cosine function, multiple points. On the tangent, multiple points. This means that the inverse of these functions will not be functions until we restrict the domain. And I'm going to show you how we can come up with that by going to graph. This is that Padawan graph on the first day of class that we helped you download. So going to graph, I'm going to insert f of x equals sine of x. And so here is just the traditional sine of x function. So now we really want to look at the inverse of this. But since it's not a function, we have to graph it as a relation. So if you recall that the inverse of a function means that we swap the x and the y. So if I go back over here, y equals sine of x, and I swap my x's and my y's, I get x equals the sine of y, which can be rewritten as y equals the sine inverse of x, which is where these inverse functions are coming from. So in order to graph that, I have to do function, insert relation because it's not a function, and we're going to insert x equals the sine of y. Make sure it's in a different color. I have it in green here. And so now you can see here is the inverse of the sine function. So you can clearly see that this is not a function. So that's why we need to restrict the domain until it becomes a function. So the first thing I'm going to do is I'm going to get rid of my sine of x because we're only going to be looking at the inverse. And I'm going to go ahead and I'm going to change my axis, my y-axis. I can click show as multiples of pi. So I'm going to click that. So now as you can see, my y-axis is in multiples of pi. So basically what I'm going to do is I'm going to zoom in until we can see this relationship becoming a function. So here, if I were to draw a line, it would still fail because we have these 2 points. So I need to keep basically zooming in. So once I've zoomed in far enough, we can clearly see that this is going to happen when the domain, which is my x values, when the domain is -1, meaning I'm going to stop right here at this, where this curve begins, and then I can go all the way until +1, again where this curve kind of starts right here. So that's going to restrict my domain from -1 to 1, which makes the range, which are my y values, from pi over 2 down to -pi over 2. So this is going to give us the full range of sine, but it's now going to turn it into a function. We can now do this process again for cosine and tangent and get the following functions. To save time, I'm just going to show you ultimately what you would get. So here is what we did just a second ago on graph for the sine function. So this is what you would get for the cosine function if you were to follow the same process that I just said. Your domain would still be -1 to +1, but your range would be from 0 to pi. For tangent, the domain is -infinity to +infinity. So keep in mind this range does not include negative pi over 2, and it does not include pi over 2. So if you're ever asked to find the tan inverse of either one of those values, they don't exist because we don't include those radian measures. So these ranges are super important because of how it limits the values on the unit circle for these inverse trigonometric functions. So we need to keep these ranges in mind when solving inverse functions. So basically what we have here on the screen is just a depiction of when we're talking about the unit circle values. For sine, again, we can only go from pi over 2 to negative pi over 2. For cosine, we can only go from 0 around to pi. And then for tangent, again, don't include pi over 2. And then we're going to go down but not include negative pi over 2. And you'll see in a minute why these pictures are very important when we go to do some examples. So this table shows the domains and ranges for all 6 trigonometric functions for your reference in case you need a reference back to any of these, since I've only talked about the sine, cosine, and tangent. The inverse functions can be thought of as almost undoing a trigonometric function. So I'm going to go and reference my completed unit circle. So here's just a unit circle that's already been filled in. So if the sine of 45 degrees, as we can see on my unit circle, is root 2 over 2, when I have the sine inverse of root 2 over 2, that's going to take me back to that 45 degrees. So it's almost like you're undoing a trigonometric function. So kind of with my little example here, you can see how we are going to be using the unit circle a lot in this section. So this is kind of why I was suggesting that you print off a copy of a completed unit circle and use it to do your homework with. So if we look at the examples that I have on my screen, the first example, we have sine inverse of root 3 over 2. So again, we're looking for what angle gives us root 3 over 2. So if I go and I look at my completed unit circle, remember that sine is our y value. So I'm looking for y values that are root 3 over 2. So here is a y value of root 3 over 2, and here is a y value of root 3 over 2. So that would be pi over 3 and 2 pi over 3. However, if you remember, I said that these pictures are very, very, very important. So as you can see, the sine, the range is negative pi over 2 to pi over 2. So looking back at my unit circle, pi over 2 to negative pi over 2, this is not in the range of sine. So that means my only answer for sine inverse of root 3 over 2 is pi over 3. Looking at this next example, we have cosine inverse of negative root 3 over 2. So I'm looking for my angle in which cosine is negative root 3 over 2. Again, referencing back to my filled in unit circle. We're looking for cosine, which is our x value, negative root 3 over 2. So I have an x value of negative root 3 over 2 and an x value of negative root 3 over 2. So remembering my picture, cosine inverse was only valid between 0 and pi. So that means that my only valid answer in my range is 5 pi over 6. This value is not in my range. So the cosine inverse of negative root 3 over 2 is 5 pi over 6. So for our last example, we have tan inverse of negative 1. So kind of what I do with our tan inverses is I just think about what are my values on my unit circle. Tangent is a relationship between sine and cosine. So the only values on my unit circle that can give me sine divided by cosine and give me a value equal to 1 is going to be the 45-degree angles. Because if I have root 2 over 2 divided by root 2 over 2, that's going to give me 1. But if you remember, it's asked to find a negative 1. So if this value has to be a negative 1, that means one of these values, either the numerator or denominator, has to be negative. So that's going to eliminate this one and this one. The tangent for pi over 4 is 1. The tangent for 5 pi over 4 is also 1. So really we need to be looking at 3 pi over 4 and 7 pi over 4. But recall when I had my picture for the tan inverse and the ranges of tan inverse, the range for tan inverse was not including pi over 2 all the way around to not including negative pi over 2. So that tells me that my only answer is going to be 7 pi over 4 because 3 pi over 4 is not in the range. So the tan inverse of negative 1 is 7 pi over 4. Just remember, the most important thing is to keep in mind the restricted ranges for the arc sine, the arc cosine, and the arc tangent.